Hello everyone. Today we're going to be solving a simple AC steady state problem defined by the following circuit, the circuit that I drew on the screen here. They gave us the value of L for the inductor, C for the capacitor, and then R for the resistor. And then they give us VG as well, being defined as 50 sine 8000 T. All right, and then they want us to find V naught, which is the voltage across the resistor. Now the first step is we're going to convert everything into phasor form or phasor notation. And let's go ahead and do that by finding the impedance of the inductor and the impedance of the capacitor, and then the impedance of the resistor, which we know is just 50 ohms. The impedance of the inductor is defined by the formula J omega L, and the capacitor is negative J over omega C. All right, so this top piece here is going to equal J times omega. So what is omega? So omega is the angular frequency here, and it's going to be 8,000, which means it's going to be 8,000 for the entire circuit. So right off the bat, we actually already know what omega and VO is going to be, or V naught, and it's going to be 8,000, and then plugging that in to find the impedance gives us 8,000 times the inductor value, which is 3.125 times 10 to the negative 3, like that. And then for the capacitor, it is negative J over omega, which we just said was 8,000, times the capacitance, which is 5 times 10 to the negative 6, like that. All right, and let's plug those into a calculator and see what we get. So 8,000 times 3.125 to the negative 3 gives 25, or J, 25 ohms. And then negative J over 8,000 times 5 to the negative 6 gives negative J 25 ohms. Alrighty, so now I say we do nodal analysis. So if we put a point here, right, and that's going to be V naught, and then we're going to ground the bottom. Alrighty, and then we can do nodal, and we're going to assume for this that all of the current is flowing, let's say flowing away from the node here, like that. So then we can say that V naught minus Vg over the impedance of L plus V naught minus 0 over the impedance of R plus V naught minus 0 over the impedance of the capacitor, and all of that is going to equal 0. Alrighty, so what are we looking for? We're looking for V naught, and it looks like we have everything else that we need. So I'm going to scoot it up a little bit to gain a little extra room. And now we can say that 0 equals, and we can expand this out a little bit and maybe plug some numbers in. So ZL is J25 minus VG, where I guess we should write that properly, shouldn't we? So moving down here, right, VG in phasor notation is going to be equal to 50, and then if we were to write that in cosine, we would have to subtract 90, right? So writing it in cosine, it's going to be negative 90 written in this polar form here. Alrighty, so that being established, we can write that as 50 angle 90. And that's also going to be over that J25 plus V naught over R, which is 50, plus V naught over ZC, which was what? Negative J25, like such. So now I can say 50 phase negative 90. Maybe I'll make that a negative J, bring that to the top there. And I'm adding it over, so the negative went away, but then we added it because we brought it to the top, okay? So then we can say that over 25 is going to equal, then we can take V naught out of each term, and then we get 1 over J25 plus 1 over 50 plus 1 over J25, and that actually has a negative attached to it, so I'll change that sign there to a negative. All right, we're almost done now. So I can say V naught is equal to negative J, and just as an aside over here, we know that negative J is the same as rotating, right, by negative 90 degrees. So putting that into play and then also doing the 50 divided by 25, we're going to get 2 with an angle of negative 90 minus negative 90 because of that negative J. All right, and then we can divide that by this piece here, which is 1 over J25 plus 1 over 50 minus 1 over J25, like such. And I guess we could have crossed this out a little bit earlier, but we'll just go ahead and cross that out now. So then this just simply becomes 100 with the angle of negative 180. So the problem asked us to find, V, omega, and phi here. So we did just that. We found the angle here. And we found this amplitude here, which we'll call V. So then we know that V is 100, angle is negative 180, and then that omega remained the same from the beginning. And the units for that are in radians per second. Well, there you have it. I hope that was pretty straightforward and pretty simple. It's not a whole lot to it, just understanding how phasor notation works and then having the background knowledge to do the nodal analysis. So I hope y'all found that helpful, and I will catch y'all in the next one.